Hello, my name is Jonathan Brown. I'm the Business Development Manager with RE2 Robotics, focusing on the Department of Defense. I'm here today to talk about the innovative work we've done for the Navy to develop an inflatable underwater robotic arm to help improve mission safety and enable longer missions for mine countermeasure missions. First, I'd like to tell you a little bit about RE2 Robotics. RE2 was founded in 2001 as a Carnegie Mellon spinout. Our founder, Jürgen Pedersen, was one of the original employees at the National Robotics Engineering Center, or NREC. We now have 86 employees, almost double the number of employees we had at the beginning of 2020. Our focus is developing innovative robotic arms with human-like capabilities. We design our systems to perform well in outdoor, uncontrolled environments on land or underwater, very different from the indoor controlled settings where factory automation occurs. We are the experts in creating robotic arms that can be teleoperated or controlled autonomously in order to interact with things in challenging outdoors environments. We can do that not only because of our industry-leading robotic arms, but also due to our expertise in developing computer vision and perception software, as demonstrated in our product RE2 Detect, and in creating autonomous behaviors with another software product, RE2 Intellect. We pride ourselves not just on doing R&D, but on getting our systems into production. We've shipped over 625 robotic systems to the DoD and to DoD prime contractors. In 2020, 2/3 of our revenue came from commercial customers, demonstrating our ability to successfully commercialize DoD-funded technologies. We serve 5 markets: the DoD, aviation, energy, medical, and materials handling. I'd like to mention a couple of products we're working on in some of those markets. We were just awarded a direct-to-phase 2 SBIR contract by the Department of Energy to automate the installation of solar panels at large solar fields. And for one of our commercial customers, we're working on a project to develop a system to autonomously perform the water service for an Airbus A320. And we're also working with the Office of Naval Research to integrate our Sapien C-class robotic arms with the Video Array Defender and to develop autonomous behaviors for mine countermeasure missions. The Navy would like to be able to integrate robotic arms with remotely operated vehicles, known as ROVs, for mine countermeasure missions, so that the ROVs can dispose of those mines by interacting with them. However, adding a robotic arm to an ROV has the potential to add size, weight, and power, or swap, impacting the range of the ROV and mission length, and potentially adding to the electromagnetic signature of the system. Also, because traditional underwater robotic arms are made of metal and plastic, any unintended contact by one of those arms with a target could have negative consequences. Our concept to address these needs is the Underwater Dual Manipulators Inflatable, or UDMI. The transition targets for UDMI are the Maritime Expeditionary Standoff Response Program of Record, known as MESSER, as well as the Low Observable, No Collateral Damage Neutralization of Underwater Mines Future Naval Capabilities Effort, also known as LONO FNC. The key performance parameters for UDMI include making it inflatable as needed, lifting objects weighing up to 25 pounds, precise positioning control, and operating to depths of 200 feet. Our overall goal for UDMI is to improve the mission safety of ROVs for mine countermeasure missions by minimizing the impact that adding robotic arms have on the overall system. This includes reducing the electromagnetic signature of ROV robotic arms, decreasing the swap that the robotic arms adds to an ROV, minimizing the possibility that unintended contact with a target could cause a detonation, particularly when the target may be moving unpredictably because of its location in a water column, and designing the arms with a view towards integrating them into an ROV program of record so that they're not just a standalone science project. Our proposed solution is UDMI, the Underwater Dual Manipulator Inflatable. UDMI consists of an inflatable arm, inflatable gripper, and inflatable actuators. These are inflated using environmental seawater, which also powers the hydraulics of the system. The pressurized membranes of UDMI use compliant elastomeric materials. One of the other neat technologies we developed for UDMI is a fluidic peristaltic roll joint at the wrist to enable continuous motion and enable precise positioning of the system. UDMI can be teleoperated. It has torque of 8 foot-pounds and a joint speed of 30 degrees per second. We've already successfully demonstrated underwater operations of UDMI in a relevant environment in our lab, achieving TRL 6 earlier this year. The fact that UDMI's arm, gripper, and actuator are all compliant and inflatable diminishes the possibility that any unintended contact with a target may have a negative outcome, increasing mission safety. When deployed, UDMI's compliant and inflatable arms have a lower electromagnetic signature compared to traditional robotic arms, also increasing mission safety. When the system is not inflated, UDMI is much lighter weight compared to traditional robotic arms, enabling missions of greater duration and distance. And when they are not inflated, UDMI is stowable, reducing the underwater drag on an ROV when they're not deployed, enabling longer missions. When the system is stowed, they have an even lower electronics signature compared to traditional robotic arms, increasing mission safety. And the hydraulic system is powered by environmental seawater, which also decreases swap, enabling longer missions. The next steps to transition UDMI to the fleet include increasing its TRL to TRL 8, integrating UDMI with an ROV that has been selected for a program of record, and qualifying UDMI's performance characteristics through testing and demonstrations. As I mentioned earlier, we are targeting the Messer program of record as well as the low-no FNC as our transition targets. For our other work for the Office of Naval Research, we've successfully integrated our Sapien C-class underwater robotic arms with multiple ROVs, including the Seabotics and the Video Ray Defender, as well as developing autonomous behaviors for mine countermeasure missions. If you have a need for a complex underwater manipulation task, or for that matter, any complex manipulation task, we are the folks who can design a system to accomplish what you need done. Please feel free to contact me to learn more about our work on UDMI, or to discuss your needs to interact with objects in challenging environments. Thank you very much for your time today.